today our objective is to hopefully remember the distance formula. So know and apply. The distance formula. And this comes out of lesson 13.1. Okay, can anyone remember the distance formula? We talked about it last year. We didn't spend a heck of a lot of time on it, but we did talk about it. Let's see. Knocknan, you got your hand up? No, that's the wrong distance formula. This is distance between 2 points. That's the distance traveled by something in motion. Okay? We spent a lot of time on that one, by the way. Okay, this is something we didn't spend as much time on. Michaela? No, that's how you learned slope, and that's not exactly it. There's more to it. It's a formula. There's a lot of stuff, and Dakota's looking in his book, so he's cheating. Okay? That's actually a slope formula. Okay? But there's application of that. No. So, let's just go to it. Nope. I'm done. Let's move on. Yeah, it's easy once you look in your book. Okay. Ooh, back, my friends. Back. All right. I have 2 lines drawn. They are perpendicular to each other. They hold significance. Can anyone tell me what the significance of these 2 lines are? Isabel? Turn them into a what thing? Okay, so what my question was is, what's the significance of those 2 lines? And the significance is one's the x-axis and one is the y-axis. Which one's the x-axis? Oh, boy, I heard somebody say vertical. That scares me. So we have 2 axes. We have an x-axis, which is also known as the horizontal axis. And we have the y-axis, which is also known as the vertical axis. Now here I can understand your confusion, because if you're drawing a vertical line that has a form of x equals whatever number your line passes through, I can see where the confusion would be between vertical and horizontal axis. Because you're thinking a vertical line is an x line. A horizontal line is a y line. But that's not how these axes are drawn. Okay, so interesting. Now, that point that they cross each other has a name. It's called the origin. Its coordinates are 0, 0. So the origin is right here, where those 2 intersect. Now, what I've done when I draw my 2 axes perpendicular to each other in this fashion, the x-axis and the y-axis intersecting at the origin, I have created how many spots? 4. And they have a name. What are they called? They're called quadrants. Now, the quadrants have a unique way of identifying them. Do you remember how we identify the quadrants? With numbers, but Roman numerals. Now, here comes the fun bit. We need to put them into our diagram here. So where's quadrant 1? And the significance of this is that the coordinates are both positive. Okay, here comes, you got a 50-50 chance of getting this one right. Where's quadrant 2? Can't be top right, buddy. That's already 1. Okay. We go counterclockwise, so it is top left. So these x's are negative, but the y coordinates are positive. And then we keep going counterclockwise. I kind of call this math Hades because everything's bad there. It's all negative. And then we've got quadrant 4, which has positive x's and negative y's. Okay. So and think about, we've done Pythagorean Theorem a million times, right? And if we had a drawing of a shape, and I wanted to figure out what the three sides equaled, well, if I drew my one side so it was parallel to the x-axis, I could figure out what the coordinates are and just subtract them, right? And I could come up with the length of that side. And then, because I have a right angle, I would have a vertical side that would be parallel to the y-axis. So all I would need to do is to take the coordinates, the y-coordinates, and subtract them and figure out that length. And then I have Pythagorean Theorem, plug those two numbers in, and then I get what I need, okay? Now, these lengths would always be positive, so it doesn't really matter what direction you subtract, but you would definitely have to take the absolute value of your final answer, because again, you can't have a negative length. So if I did -2 take away 3, that would give me a -5. But that's actually 5, because I'm just figuring out how long that piece is. I'm not, what direction did I count, okay? It's all about just how long is that piece. So we've been using the Pythagorean Theorem all along. Now, that Pythagorean Theorem is actually what we're going to use for the distance formula. If you guys look at, because already you guys were like, I'm going to get this answer right, and you opened up your books and you found it, can you see the Pythagorean Theorem in use there? Okay, so what we're going to do is do this from scratch so that you can see. Here's your x-axis, here's your y-axis. If I wanted to know the length of this line, what I could do is create a right triangle and use the Pythagorean Theorem. So I'm going to give some coordinates to my points. We'll call this point at the bottom point P, and his coordinates will be x sub 1, oops, that's supposed to be a 1, x sub 1, y sub 1, and then we'll call this point up here Q, and his coordinates are x sub 2, y sub 2. So we're going to do this very generically because this is how we're going to derive the distance formula. So if and then this point, what would be the coordinates of that guy right there? And we'll call him R. Your diagram tells you what they are. What's the x coordinate? Yeah, it's the same as the x sub 2, right? It's in the same line as the x sub 2. What's the y coordinate? It's the y sub 1 coordinate, okay? So I can figure that out just by looking at the intersection of my 2 points. And what is it the same as? It's the same as the x of q, and it's the same as the y of the p. Okay, so actually I could figure out the length of PR. So the length of PR, I would just take my x values, and I'm going to take my larger x value and subtract from it my smaller one. That way I'm not going to deal with absolute value. So that's the length of PR. Pretty easy. Okay. Well, what's the length of QR? And I'm going to do the same thing. I'm going to take the largest value of the y coordinate and subtract the smallest value. So the Pythagorean Theorem says, okay, well, now I've got a right triangle and I want to figure out what PQ is, so let's go ahead and deal with that. So we take PQ, we square it, and we set that equal to PR squared plus QR squared. So I'm just going to plug in numbers here, and let's change this guy's name to D. We'll do that in a second. So we've got PQ squared is equal to, we said PR was the quantity x squared minus, or x sub 1 minus, x sub 2 minus x sub 1, and we're going to square that. And then we're going to add to that QR squared, and QR is y sub 2 minus y sub 1 quantity squared. But again, I'm not solving for PQ squared. I want to know what PQ is. So remember I went back and I said I'm going to rename PQ as D. So if I don't want to know what D squared is, I want to know D. If I don't want to know what PQ squared is, I want to know PQ. What do? I got to take the square root of both sides. Now, honestly, when I take the square root of a variable, I should be writing plus or minus on the other side. But does it make sense that we would come up with a negative length? No, so we exclude it and we focus in on the principal square root. So we get d, the length of that diagonal, is equal to the square root of the difference in the x's squared plus the difference in the y's squared. And that, dear friends, is the distance formula. You brought me treats? Oh, awesome. Thank you so much. Yay. Okay. Oh, gosh, it smells so good. So this is not some weird, strange thing. This just happens to be a derivation of the quadratic formula using the coordinates. That's why this unit is called coordinate geometry. We're using the coordinates from a graph to help us in with our algebra skills to help us in our geometry class. Okay, so let's do some practice. So I guess I have to write this down. We do have to add this as a card. This is Theorem 13.1, which has the name, strangely, the distance formula. Do you realize you're my only class I get to teach today? Everybody else is testing. It's crazy. The distance, d, it's questionable that I'm teaching today. Between points x sub 1, y sub 1. Actually, the more questionable thing is, are you learning today? And x sub 2, y sub 2. That, Weedhopper, is up to you to decide to learn or to ignore. Is given by d equals the square root of x sub 2 minus x sub 1 quantity squared plus the quantity x. Come back here. Y sub 2 minus y sub 1 quantity squared. Now, here's kind of the little miracle that occurs. This is the one rare formula that if you swap order, it's actually not going to affect your answer negatively. Okay? Because remember, whatever difference you get, you're going to square. You'll always get a positive. So there's no issues here. That's why we don't have to deal with absolute values with this, because we're squaring the result of the subtraction. Does it matter if you put the y terms in front and then the x terms in the back? No, it doesn't matter. Okay? All that matters is that you subtract your x's, square it. You subtract your y's, square it. Add those together, and then, Kai, take the square root. Josiah.
So you could do x1 minus x2.
Yep. It's kind of funky that way, but here's the deal. This is like one of the rare exceptions in math where order doesn't matter. I would say 99.9% of the time order does matter. So don't be going, woohoo, now I can go out of order, because then you're going to get a little bit lazy in the ones that it does matter, and we'd have disaster. So let's try to avoid disaster if we can. So let's do a couple of examples. Directions are going to say, find the distance. Hi.
Hi, can I interrupt you?
Sure. All right, find the distance between the points. If I just said 2 points, you'd be in trouble. I have to be a little bit more specific than 2 points. 2, -1. Now, yes, you could graph this. You could count how long each of the sides are, the vertical side and the horizontal side, and you could plug it into Pythagorean Theorem. That's a lot of coulds. If they don't provide you a graph, I would never even think to do it that way. I just plug it into the formula. D equals the square root of -4 take away 2 quantity squared plus the quantity 2 take away -1 quantity squared. The two negatives make a positive. And then we just keep doing math. So -4 take away 2 is, by the way, -6, not -8. And we have 3 squared. So -6 squared is 36. 3 squared is 9. And we get the square root of 45. Now, we still have some rules that we have to remember. and the rules we have to remember about radicals is there's no perfect square factors left under the radical, there's no fractions under the radical, and there's no radicals in the denominator. So is there a perfect square factor of 45? Okay, 9 and his partner is 5. So we take the square root, and we get the answer is 3 radical 5. Okay? All right, so let's take this and let's kick it up a little wee notch, because again, this is a review topic, not a new topic. Next question. Find an equation of a circle with center 5, 6, and radius of 4. Find an equation of a circle with a radius of, or with the center of 5, 6, and a radius of 4. So basically we're going to kind of back our way into our next theorem, which is how do you write the equation of a circle. Okay. So let's draw a picture of our circle. This point is at 5, 6. We have a radius of 4. What I need in any formula is usually an x and a y. So I'm going to say that the point that the radius ends up on the circumference, we're going to label him, well, actually we could just label him x and y. We don't need to do x sub 1, y sub 1. So if you think about it, the reason why I did that is because now I'm creating a right triangle. So I can use the distance formula, right? Because the distance formula, again, goes back. So if my distance formula is distance equals the square root of my x's squared, and x's subtracted then squared, and then added to my y's subtracted and squared. What's the d in this question? The distance is that 4. It's the radius, plays that role. Now, I'm going to put the x in the front and then minus the x coordinate of the center. And what's the x coordinate of the center? 5. And then we're going to square that, and then we've got the y is going to go in front, and then minus the x coordinate, the y coordinate of the center, which is 6. Now, this is not an equation I've ever seen where my variables are stuck underneath the radical, so what could I do about that? I could square both sides. And I end up with the quantity x minus 5 squared plus the quantity y minus 6 squared equals 16. This is called the formula for the area of a circle. It reveals your squared radius. So if I take the square root of this number here, I know what the radius is. If I set each one of these to equal to 0, it tells me the coordinates of the center. Okay? So this value and this value sorry, that's a 5. I'm always a step ahead in my brain. Pretty cool, huh? So it reveals the vertex, or the center of the circle. Ding, ding. And it reveals the radius. Okay? So we're going to write that down as an official value. Everybody good? Theorem 13.2 without a name. So sad. An equation, or the equation of the circle with center AB, A comma B, and radius R is x minus A quantity squared plus the quantity y minus B squared is equal to your R squared. Okay. So again, where a lot of people get confused is what do they write as the coordinates of the center of the circle, and they tend to take whatever comes after the x, and they say, oh, it's a negative A and negative B. Remember, that quantity in the parentheses sets equal to 0, so the sign you get for your coordinates is opposite to what it looks like in the formula, because the formula contains a minus. Okay? So in other words, if I give you this guy, and I say, you know what, I want you to sketch this circle. First job is to identify the center. Second job is to figure out the radius. So, what's the center of this particular circle? Dakota. And he did exactly what I said you shouldn't do. It's not negative 1, 2. Okay? Yeah, remember, take each of these, set it equal to 0 if you are you avoid mistakes at all costs. So we have the center is 1, negative 2. What's the radius? Yeah, we take the number here and we take its square root. And that gives us 3, which is the radius. So when you sketch, let's see. And when I do mean sketch, let's see, we're at 1, negative 2. Hello, PE. Actually, let me go up a little higher. Oh, pardon, that's supposed to be positive 2. And this is 2. So what I do is I put in my center, 1, negative 2, and then I have 4 points that I can easily graph. Those 4 points would be like the compass rose, right? We're going to go 3 to the right of the center, 1, 2, 3. We're going to go 3 to the left of the center, 1, 2, 3. We're going to go 3 down from the center, 1, 2, 3. We're going to go 3 up from the center, 1, 2, 3. And then we could use a compass, and then we sketch.